All right, I'm back. Now you had a chance to read this problem. You got a plane. It's flying at an altitude of 10 kilometers. Altitude, of course, measured on a right angle, 10 kilometers, therefore being that leg of a right triangle. The pilot in the cockpit here. I guess we could draw a little pilot. He's hanging out of the cockpit there. And he is seeing a tower off in the distance. So he's flying the plane. He's looking out down at a tower. And now here's this phrase. Here's a vital phrase. Angle of depression. Depression, of course, meaning down. So if the pilot is looking straight ahead of him or her, that would be said to be 0 degrees. So angle of depression means starting at 0 and going down. Down from horizontal. All right, so down from horizontal, if 0 degrees is this way, we're looking at 18 degrees this way. If you remember from geometry, parallel lines, alternate interior angles, this one would also be 18 degrees, but it is definitely not there. All right, so 18 degrees can go in either one of those places. Since horizontal is parallel to horizontal, this would also be 10 kilometers, so it doesn't really matter, since we've got a rectangle with a diagonal drawn here, which height you use or which horizontal you use, because ultimately that's what we're trying to find. How far is the tower from the point on the ground directly below the plane? So ultimately we're looking for this distance right there. So what do we have? What do we know? What do we want to know? We know the opposite. We want the adjacent. What do opposite and adjacent combine to make? We'll use tangent. So tangent of 18 is equal to 10 over x. So take a second and figure that one out. So we have 10 divided by tangent of 18. Oh, that's wrong. How am I getting a negative? Oh, yeah, degrees. So 30.7. What's 30.7 kilometers? So why don't you go ahead and look at parts 3 and 4, and I'll come back with a couple of drawings and help you through if you might have had any troubles. All right, back with a couple of pictures to help you along. The building has a smokestack on top of it. You are 500 feet from the building. So that's this distance here. The angle of elevation, so elevation means up from horizontal. So you're looking up at the top of the building at a 25-degree angle, and you're looking up at the smokestack, at the top of the smokestack at a 32-degree angle. So what you're going to need to do is use the 25 to find B, then use the 32 to find T, and then the purple, the smokestack itself is going to be red minus blue. And then for number 4, first of all, knots is a knot is a nautical mile per hour. So if they start at noon and travel for 2 hours, they've gone 40 knots, or 40 nautical miles west. That's the blue. Then at 2 p.m. they change direction. This is called a bearing. How to read a bearing. You for north, 54 degrees west, you start by facing north. And then, oops, sorry about that. You start by facing north. And you turn towards west 54 degrees. So to draw the bearing north 54 degrees west, you start by facing north and you rotate 54 degrees towards the west, which would be this guy. Then travel for one additional hour because we're ending at 3 p.m. The distance from the port would be represented by x. the bearing to the port would be represented by the purple angle. So take a few minutes, maybe that's helpful, and then revisit when you think when you want to go. Okay, so we're back. Number 3, we've got our smokestack all calculated. We've used tangent because in both instances we have the adjacent 500. And we want the opposite, whether it's B or whether it's T, it's always the opposite. And then once you find B and T, subtract to find S. Number 4 is a little bit tricky because what you really need to do is once you have that bearing in place, you need to imagine this little added triangle to complete a right triangle. So we've got it over here. This angle down here is 36 degrees because we would subtract from 90 to find this guy right there, so that would be this angle. Use what you know with sine and cosine to find the dimensions of this green triangle. Add in that green triangle to the big thing, because this would be the same as x over here. 56.2 would be the side of the blue plus the green here, blue plus 40 plus b. And now what you've got is the distance, because here's still the port, and here's the ship. It doesn't really matter what happened in the interim. The distance from the port to the ship is the hypotenuse of this one. Probably use Pythagorean theorem in this particular case to get 57.4 nautical miles. And then the bearing, again, a little bit tricky. Angle Z here would be the bearing. What you could do is probably inverse tangent. So Z would be the inverse tangent of 11.8 over 56.2. And so Z would be 12 degrees, but that's not quite the bearing. You have to give it some kind of reference point from north and west. So again, if we go back to our drawing here, if this is a 12-degree angle, just do it in purple. 12 degrees. We now have to give it a bearing from north to west. We could say the bearing is north. What's this angle right here? 78 degrees west. And there we have it. Okay, so that's your distance and the bearing. So as usual, let's go over the important ideas from this lesson. We talked a little bit about solving a right triangle, and that is all about finding all of the missing sides and all of the missing angles. You can use some combination of inverse trig functions. That'll solve angles, and some combination of SOHCAHTOA, Pythagorean theorem, to find side lengths. Next thing we talked about was in word problems, you'll often see the words elevation, the angle of elevation, and the angle of depression. Remember, the elevation is upwards and the depression is downwards, but it's really important that they have a reference point of horizontal. So an angle of elevation starts at horizontal and goes upward. And an angle of depression starts at horizontal and goes downward. Again, always rooted in horizontal. Last thing was a bearing. A bearing was a navigational term. And it simply gives a reference point, an angle towards another direction. So north 40 degrees east would be starting at north and turning 40 degrees towards the east. And you could also have something like south 70 degrees west would be starting south and turning 70 degrees to the west. And so this angle would be 40. And then, in context of the problem, the 40-degree angle might be relevant. The 50-degree angle right here might be relevant. So contextually, you need to make sure that you are considering the entire problem. So let me know if you have any trouble. We will debrief all of these check your understanding problems in class, and I'll see you then.